Hello everyone! In our previous discussions, we've seen how changing the temperature can change matter, like when ice melts into water or water boils to become steam. But is temperature the only thing that can do this? Today we're going to explore another very important factor, pressure, and see the amazing effect it has on the states of matter.
So this brings us to a very interesting question. We know that if we cool a gas, we can turn it into a liquid. But is that the only way? Can we perhaps change a gas into a liquid using some other method? Let's find out. All right, to understand this, we first need to quickly remember some basic properties of gases. This little recap will be very helpful for everything we're about to learn.
Now, if you recall, the particles in a gas are very far apart from each other. There are large empty spaces between them. And because of these large spaces, gases have a special property. They are highly compressible. This means we can easily squeeze them and force the particles to come close.
And what is the tool we use to squeeze these gas particles together? Well, that's what today's topic is all about. It is the power of pressure.
So what exactly do we mean by pressure? Imagine the particles of a gas are like tiny balls moving around randomly at high speeds inside a box. They are constantly hitting the walls of the box. This constant hitting creates a force. Pressure is simply that force applied by the particles on a certain area of the container's wall. Let's repeat that so it's very clear. Pressure is the force exerted by gas particles per unit area on the walls of the container.
Now, when we apply pressure from the outside, like by pushing a piston down into a cylinder, what happens? We are basically forcing all those gas particles into a smaller space. This makes them come much closer to one another.
A very simple way to see this is with a syringe. Imagine we have 3 syringes. One is filled with a gas, like air, the second is filled with a liquid, like water, and the third is filled with a solid, like chalk powder. Now, if you try to push the piston in each one, what will you find? For the syringe with gas, the piston will move in very easily. For the liquid, it will be quite difficult to push. And for the solid, the piston will not move at all. This clearly shows us that gases are highly compressible compared to liquids and solids.
So, because gases can be compressed so easily, it leads us to a very interesting possibility. We can actually change a gas into a liquid. This process is known as liquefaction. So how is this done? It's actually a 2-step process. First, we apply high pressure. This squeezes the particles and brings them very close to each other. But just bringing them close is not enough because they still have a lot of energy and are moving around very fast. So that brings us to the second step. We also need to reduce the temperature. Cooling them down removes their energy, slows them down, and allows them to settle into the liquid state. So remember, it's a combination of applying pressure and reducing temperature.
And you see this principle in action all around you. The LPG or cooking gas cylinder in your kitchen contains petroleum gas that has been turned into a liquid under pressure. The CNG used in many cars is also natural gas, compressed to a high pressure. Even the oxygen cylinders that are supplied to hospitals contain oxygen gas that has been liquefied so that a large amount can be stored in a small cylinder.
Now, we usually think of the states of matter changing in a sequence, solid to liquid, then liquid to gas. But nature has some shortcuts. Let's talk about a fascinating process where matter can jump a step, in what we call sublimation and deposition. First, let's talk about sublimation. What is it? Sublimation is the change of state directly from a solid to a gas, without becoming a liquid first. Let's just pause on that. It goes straight from a solid into a gas. It completely skips the liquid phase. A classic example of this is camphor, or Kapur, which you may have at home. If you take some solid camphor and heat it gently, you will notice something interesting. It doesn't melt into a liquid. Instead, the solid camphor turns directly into camphor vapor, which is a gas with a strong smell.
Now, what if this process happens in reverse? What if a gas turns directly back into a solid? Well, this process is called deposition. It is the direct opposite of sublimation. A gas becomes a solid, once again completely skipping the liquid state.
A perfect example to understand this involves a very special substance. I'm sure you have heard of carbon dioxide gas, but have you heard of solid carbon dioxide? It's a real thing, but it can only exist as a solid when it is kept under very high pressure. This solid carbon dioxide is famously known as dry ice. Why is it called dry ice? Because unlike normal ice, it never melts to make a puddle of water. It's never wet. Instead, if you decrease the pressure, for example, by just leaving it out in the open, it turns directly into carbon dioxide gas. This is a perfect example of sublimation happening because of a change in pressure.
So, we have discussed quite a few things today. Let's bring all our ideas together. We have now seen that there are two main factors, two master controls, that decide if a substance will be a solid, a liquid, or a gas. And what are those two controls? First, we have temperature. Changing the temperature changes the energy of the particles, how fast they move. And second, we have pressure. Changing the pressure changes the distance between the particles, how close or far apart they are.
So, the most important takeaway from this discussion is this. We can confidently say that pressure and temperature together determine the state of a substance. They both play a role in whether something is a solid, a liquid, or a gas.
And with that understanding, I want to leave you with one final question to think about. We know that if we heat water to 100 degrees Celsius, its boiling point, it turns into vapor. But think about wet clothes drying on a clothesline. The water from the clothes also turns into vapor and disappears, but the clothes are certainly not boiling. So how does that happen? That is a mystery we will solve in our next explainer. Thank you.